I can probably, it's probably a question already on one of the reviews. So if you guys have anything for me, let's start this off, and we'll go as far as we can go here with the time. So whatever you guys have for me, go ahead and ask away.
Can you do the last one on the tougher triangle proofs?
Sure. So let's go to the tougher triangle proofs. Okay, this one right here, give me a second so I can copy and paste it. Paste. There we go. Okay, this one wasn't joking around here. All right, this one was a pretty tough one. Maybe right from the beginning, it might have scared some of you off because we had, hey, prove PQ bisects angle RPS. PQ bisects RPS. So to even do that, or to begin talking about proving that, if PQ is going to bisect angle RPS, I needed to first prove that angle RPQ was going to be congruent to angle SPQ. Let me rewrite that first one. So angle RPQ. I did it again, one job. There we go. Okay, so I needed to prove angle RPQ congruent to SPQ, and then I could say, hey, PQ definitely bisects angle RPS. So how am I going to do this? How am I going to show those two angles are equal to each other? There's a couple different ways. I see this triangle and this triangle both contain those angles, so I could prove those two triangles congruent. Or I do see another pair of triangles in here that could be a possibility. I could do triangle PTQ congruent to triangle PQU, because both of those triangles, again, contain RPQ and SPQ as full sides. I could prove them congruent and then say CPCTC. It really depends on the information I have available to me. So let's see what's given. And then I'll pick which two triangles to use. I have PT congruent to PU, and I have PR congruent to PS. Whew, well, let's see here, guys. Honestly, the two pairs of triangles I just showed you, I have one pair of sides on each of them. All right, so I don't think it's really going to matter which one I pick. I might end up being able to prove one or the other, but I won't know that until at least I just pick a pair right now and go towards it. All right, just let me cheat real quick and see what I did on my answer key here so I know which way to go. I proved PRQ and PSQ. PRQ and PSQ. I had to do a couple different triangles there. TPS and UP. PRQ and PSQ. Okay, so I'll go with them. All right, so I'm going to go with the two smaller triangles, PRQ and PSQ somehow. I'm going to try to get those congruent. I already have a pair of sides done. All right, I already have a pair of sides. So let's set this up. And this one was as hard as they get right here. All right, this one was as hard as they get. Just to save time, I'm not going to write the givens in. We already know what they are. Okay, so I look at those triangles right there. I already know PR and PS are congruent. That gives me a pair of sides. So I just want to make sure I remind myself, hey, I have a pair of sides right there. Next up, I can see PQ congruent to itself. PQ congruent to PQ, reflexive. And that gives me another pair of sides. So I have all the sides I need right now. Now I got to figure out, all right, is there anything else I can do? Doesn't look like it. All right, doesn't look like I have anything else available to me right now other than those two pairs of sides. So like we did in class last week, I need to find a pair that I can prove congruent. All right, is there a pair of triangles here that I can prove congruent? And this is why this proof is so difficult, is it doesn't show itself right away. So a lot of the ones we did in class, it was like, oh, all right, I know what you're talking about, and I can prove these triangles congruent very easily. And maybe, I don't think you guys can see it as easily here, but it's the two overlapping triangles right here and right here. Okay, I can prove those triangles congruent right now. Again, why? Go back to my givens. I have PR and PS. There's a side, everybody. All right, I also have PT congruent to PU. There's another full side. And I don't know if anybody else sees what I'm missing right now to prove those two overlapping triangles congruent, but it's going to be angle P congruent to angle P, that whole angle right there. So I can say side angle side, those two overlapping ones can be proven right now. And that's what I want to do. The triangles I need aren't congruent. So now I go to a pair that are congruent, and it's those two overlapping ones. Once I say that angle RPS is congruent to itself. Another reflexive, and I could have put this in statement 2, but I didn't know it was coming. And now I could say triangle, let's see here, RPU is congruent to triangle. If I go RPU, let's see, I got to go SPT, it looks like. And that method's going to be side angle side. Okay, the reason why we prove another pair of triangles congruent is, are there any parts, full sides or full angles in those two triangles I just proved congruent by side angle side that are also in the ones I'm looking for right now, which are the smaller ones, RPQ and PSQ. So let me get rid of all this and go back to my triangles. If you remember, I had RP and PS and my reflexive side in those two small triangles, right? Well, if you look at those two overlapping triangles that we just proved congruent, many people would say, oh, look at angle RPQ and angle PSQ. Those are congruent by CPCTC. They're in the side angle side triangles. Yeah, that's true, but look where they are right now. Are those angles going to help me out proving the triangles I need, RPQ and SPQ? Probably not, right? Because those angles are not in between the two congruent sides. So this is not side angle side. So you can put it in your proof that those angles are congruent by CPCTC, but it's not going to help me at all. Okay, it's not going to help me prove those triangles congruent anyway. All right, so I need to go to something else. All right, I need to go to something else pretty quickly here. And let's see, anything else? RPU and SPT. Let's see, anything else going to help me? I don't think so, guys. I don't think anything else is going to help me with those triangles. So in this proof here, and I don't want to keep going on here and just adding more time to this proof, but what ended up happening in this proof is, okay, those triangles were congruent and it didn't help me get to the ones I needed congruent here, triangles 1 and 2. So what I needed to do was prove another pair of triangles congruent, and those triangles were right here, PTQ and PQU. I can prove those triangles congruent now, all right, because I proved those two overlapping ones congruent. We could say that now angle T and angle U are congruent by CPCTC. Okay, because they were in the side angle side triangles. I just proved congruent, those two overlapping ones. All right, you had already PT, you had, let's see, side, let's see, this is going to be the side that we had, we had angle U congruent to itself. Let's see, where else did we have? And then we had another pair of angles, I believe, from, let me just check. This one is tough, huh? Yep, T congruent to U, then PRU congruent to PST, and then you had the supplementary angles to get TRQ to say RQ. Okay, that's what it was. All right, that is what it was. Sorry, guys. Let me just bring this back again. We can prove these two right here. Okay, so after we prove those side angle side triangles, we could say angle T congruent to angle U. And then we had these angles I just mentioned that weren't going to help us out. They're congruent by CP/CTC. So then we could say their supplements are equal right here and right here. Their supplements are equal. And then we'd have RT congruent to SU CP/CTC. All good so far? So those triangles are congruent by angle side angle. And then finally, what did that get us? By proving those two triangles congruent, you could get RQ congruent to SQ, and now we would have side, side, side. Okay, now we would have side, side, side. Those top two triangles finally are congruent. CP/CTC, those two angles we needed are congruent. And then at the end, just to review, whatever step it was, let's say step 10, we say PQ bisects angle RPS. Now, I don't want definition of a bisector. You can just tell me, why is PQ bisecting that angle? Well, we just proved in the step before that by CP/CTC, angle RPQ is congruent to angle SPQ. Okay, so that's a good enough reason. I just wouldn't put definition of a bisector there. So one last go around here, because I know we were jumping all across the board here. We needed these two triangles congruent. All we had was side, side, and nothing else. First pair of triangles we proved congruent are these two overlapping ones. We proved those two overlapping ones congruent. So we could say CP/CTC, angle T congruent to angle U. Angle PRQ congruent to PSQ, CP/CTC. So we could say the supplements are equal and get a second pair of triangles congruent, these two right here, by angle side angle. CP/CTC gets us a side RQ and SQ. So our top two triangles could be congruent by side, side, side. So we proved a pair to get another pair to finally get our pair we needed. So 3 pairs of congruent triangles in this proof. Will it be that tough tomorrow? No, but I can guarantee you tomorrow the one on the test will be at least proving 1 pair congruent to get another pair congruent. All right, I can at least guarantee that. One of the tougher proof I mentioned in class will be prove 1 pair of triangles congruent to get another pair congruent. All right. All right, let's keep going here. Others that we want to take a look at, anything from the packet, the stuff I put on Classroom or your textbook. Go ahead. The proof number 1 on the packet. And if I'm doing the wrong one, let me know. All right, so packet number 1, here we go, everybody. Copy, paste. All right. Conveniently, everything is already marked for us. We have to prove FGE congruent to DBC. Now, I notice FGE is inside one of the triangles and DBC is outside. But it does look like I can prove those two triangles congruent in a couple steps here. I already have two pairs of sides. The two givens are sides. BE and GE are congruent. AE and FE are congruent. All I need to say to make the triangles congruent is that the vertical angles are congruent. So angle AEB is congruent to angle FEG. Vertical angles are congruent. And that gives me a pair of angles. So I have enough now to say the triangles are congruent. Triangles AEB and FEG. By side angle side. All right, so now the triangles are congruent. Now, I'm not going to be able to get to these two right away by saying CPCTC, because you guys know CPCTC can only be used for actual angles and sides in a triangle, and DBC is not inside one of my triangles. But I can do this. I can say that FGE, one of the angles I'm trying to prove congruent, isn't congruent to DBC yet, but it is congruent to its corresponding part, which is angle ABE. All right, let me mark it on my diagram. Angle FGE and angle ABE. Those are corresponding parts, so because their triangles are congruent, so are they. CPCTC. I do notice a relationship between angle DBC and angle ABE. Those are vertical angles, and they're congruent. Again, I've preached this in class, and I'll keep preaching it today. Vertical angles should all go in their separate steps. Try not to put all the vertical angles in one step. It gets confusing, and you don't know when to substitute, when not to substitute. So vertical angles are congruent. Now look at my last two steps. Look at my last two steps. You see that FGE and DBC are both congruent to the same angle ABE. So that's gotta mean that they're going to be congruent to each other. FGE congruent to DBC. All right, not by CPCTC, because remember, DBC was not contained in any triangle, but by now, steps 4 and 5, put them together, we can use substitution. All right, we can use substitution to say those two angles are equal. All right, so still proving triangles congruent, still using CPCTC, but just not for our final reason. Other questions, comments? Let's keep it going. Before anybody else asks anything, let me just take a break real quick. And I know I did this in class on Friday, but I want to do it again, especially the first part of the test tomorrow. Side, 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 angle, side, angle, side, angle, 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 side, and please don't forget about HL, only in right triangles. Okay, those are your only methods tomorrow that can be used to prove triangles congruent. Please don't make up your own method. All right, because the first part, I think the multiple choice questions at least are the first non-4 algebra questions. The first 4 questions on the test tomorrow are, here's a diagram, here's some information, what postulate could be used to prove these triangles congruent. And you guys have these 5 and only these 5 available. And please don't forget about HL. All right. And also, please read, and here's another thing too, while we have a little break in the action, please read the questions carefully, all right? Before I came on to do this review today with you guys, I looked through the test again, and reading's a huge part of it. And here's what I mean. You may get a question tomorrow where you have an isosceles triangle, and somewhere in the directions it may say AC congruent to BC, but a lot of people are just going to see in the directions it's isosceles and do that. Even though it clearly says in the directions it's AC congruent to BC. All right, so please read, especially with isosceles triangle problems, what are the congruent sides? All right, just don't read isosceles and put a little hash marks on the right and left side of your triangle. Read it carefully. All right, please read it carefully. Also, another thing, and I'm telling you guys this because you guys have joined, so I may give you guys some extra info I didn't give on Friday. You guys know we have our exterior angle theorem, right? I'll just do this. I'm totally making this up right now, so I'm not going to do it out because I have no idea what the answer key might say. 3x minus 2, 2x plus 1, 6x plus 8. All right, we should all be ready to roll. 3x minus 2, an exterior angle, is equal to the sum of its two remote interiors, right? That's not what I'm worried about. I'm worried about what you're going to put down for an answer here, because I may ask for find the measure of angle BCA. BCA. Not one of the angles I labeled 3x minus 2. Follow the letters. BCA. Guys, I'm looking for that angle right there. And I think a lot of you might just give me the exterior angle, BCD, because it's got something there already. It's got a 3x minus 2, so it's just convenient to plug it in and I'm done. Read the directions carefully tomorrow, please. All right, read the directions carefully. Okay? That's my one huge warning to you guys. Read everything over again, and don't forget about HL, I guess. It's my second warning. All right. So I just wanted to make sure I got that across before we ended our session. Not that we're ending it now, but more before I took any more questions anyway. All right, back to you guys. What else do you want to discuss with me? Packet, proof 3, everyone. Let's see where we're at. All right, yep. This is a good prove a pair to get a pair proof. Similar to what one of them will be tomorrow. Also, remember, the other proof tomorrow will involve an isosceles triangle somehow. I'll either give you the triangle's isosceles, you don't have to prove something, or I will ask you to prove that the triangle is isosceles. So make sure you know, how would I prove a triangle's isosceles? By either proving two sides or two angles congruent. So make sure we are good to go there. All right, and the other proof will be similar to what I'm doing right now, which is a tougher triangle proof. Okay, what do we got here? 1 and 2 are equal. We got 3 and 4 equal. We got S is the midpoint of IC. All right, I know what's happening there. What do we got to prove? ISO and CSO. All right, so first thing due tomorrow, what do I already know about the two triangles I'm asked to be proven congruent? I know that IS is congruent to SC. Definition of a midpoint from the givens. So I have a pair of sides already. I also see a side that they share, OS. So that I can use that. OS congruent to itself. Reflexive. That gives me a second pair of sides. All right, and then I keep searching. Let's see, can I prove the third pair? Nope, I can't prove the third pair. I am not going to assume those are right angles because I have nothing about the lines being perpendicular. Let's see, that's not an isosceles triangle, so I can't do any of those theorems. I'm stuck. All right, I have two pairs of sides, and I am not getting anything else out of those two triangles. So move on. Move on to a pair that I can prove, which looks like the top pair there, IMO and CMO. I already have two pairs of angles. And then once I say MO is congruent to itself, another reflexive side. And yes, I could have put it in statement 3 if I wanted to. Once I have that, then I could say those two top triangles are congruent. Triangle IMO congruent to triangle CMO. What do I have there? Angle side angle. That reflexive side is in the middle. All right, now here comes what I think is the toughest part about these proofs, is finding a pair of corresponding sides or angles that are in these triangles we just proved congruent and also in the ones I'm asking you to prove congruent. I think this is the toughest part of these proofs, is finding something they have in common as far as full sides and full angles go. So we search. Hopefully, eventually you'll see, oh, wait a second. They have side IO and side OC in common. All right, and that could be a pair of sides that would make my proof statement triangles congruent. And what do I know after I prove the angle side angles triangles congruent? What do I know about IO and OC? Oh, they have to be congruent by CP/CTC, because those are sides in my angle side angle triangle, which gives me at the same time a third pair of sides in the triangles I'm trying to prove congruent. So ISO, triangle ISO, congruent to triangle, what was the other name of that one? CSO, by side, side, side. Okay, so very, very similar to the tougher proof you'll have tomorrow. All right, maybe the one tomorrow is a little bit tougher as far as finding those that third pair that you need. All right, but this is basically the gist of what you can expect tomorrow on the tougher proof. Prove a pair of triangles congruent to give another pair congruent. Other questions? Here we go. Let's keep it going. Other problems, topics you want me to discuss? All right, here we go. Let's see what this one involves. Proving it's isosceles. All right. Paste. Okay, so let's talk. First, the proof statement. Prove FBC. FBC is isosceles. So right now, just off to the side here, I'm going to jot down the two things, well, one of two things that needs to happen for this triangle to be isosceles. I can either prove FB congruent to FC, it looks like. You know, I could prove FB and BC, but it looks like it's probably going to be FB and FC congruent. Or instead, I could prove the angles across from them are congruent. Angle FBC congruent to angle FCB. Doing either, I don't need to do both, everyone. I don't need to do both. Once I accomplish one, I'm good. All right, once I accomplish one of them, I'm good to go. All right, so I'm either going to do FB congruent to FC, or I'm going to do angle FBC congruent to angle FCB. All right. Now I take a look. I see if I take a look at FB and FC, all right, well, that could get me, if I could prove these two triangles congruent, then I could say CP/CTC FB congruent to FC. That's one option. If you wanted to go the angles instead, you could go these two overlapping triangles, EBC along with DCB congruent. I could prove those two overlapping ones congruent as well. And I think I'm going to do that. All right, just looking at what I'm given here, I think I'm going to do that. So what I'm going to do, guys, is try to prove these two triangles congruent. So then I could say CPCTC, get those angles congruent, then it's going to be isosceles. All right, so I think I'm going to go that route. Okay, how do I get these two overlappers congruent? Well, let's start with the givens. AB congruent to AC. Stop, I'm going to stop there. That's an isosceles triangle. Triangle ABC is isosceles, so I know across from AB and AC, which are angles ACB and angle ABC, they have to be congruent. In a triangle, congruent angles are across from congruent sides. And hopefully I'm not making this a mess, but you guys see how I have now an angle in my yellow triangle and an angle in my blue one. Let's keep going. I also know that AD is congruent to AE. So what I'm going to do is I'm going to subtract. I'm going to take AB minus AD and say that value is equal to AC minus AE. Subtraction. And then what happens when I subtract those? I end up getting DB congruent to EC. Substitution. Now I have 1, 2, 3. I have a pair of sides and a pair of angles. I just need one more pair of something. And anytime triangles overlap, most times there's going to be some reflexive angular side that they share. And in this case, it's BC. Congruent to itself. Reflexive. Now the triangles I wanted are congruent. Triangle DBC is congruent to triangle ECB. What's that? Side angle side. And now let me go up. Remember my plan. I said I either needed FB congruent to FC or those angles congruent. Well, guess what? The angles are now congruent by CPCTC. So angle FBC congruent to angle FCB, CPCTC, and now that triangle is isosceles. Triangle FBC is isosceles. What happened there? Of course, what a good way to die, right? Let me just pull that right back up, guys. Sorry. Just working it too hard here tonight. Not used to a Sunday night show. What are the odds? Oh, all right. Still there. Good. So now triangle FBC is isosceles. And the reason, well, what did I just prove in step 7? 2 congruent angles. I have 2 congruent angles, and that implies an isosceles triangle. Again, is this the only way to do the proof? I don't know. I just saw those. I could prove those 2 overlapping triangles congruent to get to here, the angles, so I went with it. Remember what I showed you at the beginning of the proof? If it was possible, maybe those 2 triangles could be proven congruent. So you could say CPCTC, FB congruent to FC, then it would still be isosceles. I don't know. Maybe it would be. I don't know. Okay, just by looking at it right now, I don't know. Because I could get BD congruent to EC by CPCTC, right? By subtraction, substitution like I did. And then I would have vertical angles here. And then I don't see anything else right now. Maybe you could prove a different pair to get a another corresponding side or angle, but I'm going with my two overlapping ones I showed you at the beginning. But maybe this is possible what I have up on the board right now. All right. So there might have been a different way to do it. All right. So proving a triangle isosceles, similar to what you'll see tomorrow. Okay, very similar to what you'll see tomorrow. So all my best advice, make a plan. Okay, you guys saw how I started this out. Oh, you want me to prove the triangle's isosceles? Here are my options. I'm either going to have to get FB equal to FC, or like I did in the proof, get angle FBC congruent to angle FCB. Those are my options. Make a plan, pick one, what's the best for you. All right, maybe that might be a good idea to do that on the isosceles triangle proof tomorrow. Next up, other questions you guys have. Packet proof 4. Yep. Let me get the packet back up. All righty, here we go. Whew, 11 different angles I've labeled. Okay, there we go. Make that one fit here. Yep, we're good. All right. Okay, looks like there's a lot going on here. I look at the proof statement right away because I always want to make a plan first. BC congruent to EF. Okay, I see those two. I know, hey, I'm going to have to prove a pair of triangles congruent before I go anywhere. So I see BC and EF. So I could prove these two triangles congruent. All right, there's one way. I could prove those two, BC congruent to EF. I see another pair of triangles that contain BC and EF. I could prove these two congruent. That contains BC, and this one contains EF. So I have my choices here. I could prove the left and the right side, or I could prove the top and the bottom ones. I'm going to make a decision based on what's given to me. So let's take a look at our givens. I have angle 2 congruent to angle 3. I have AE. Where's AE? This bottom bad boy. AE congruent to BD on top. And I also have AB congruent to DE. All right, so based on what I just shown you, there's no doubt in my mind that I'm going to prove the top and the bottom ones congruent. Okay, so here's my plan, everyone, because I'm going to erase this in a second. Prove these two triangles congruent. Why? Because I have more information on those two than the ones on the left and the right. I already have a pair of sides and a pair of angles on the top and bottom one, so why not just go with it? Let's find one more pair of something. So hopefully everybody's all good. I have a pair of sides right here in AE and BD, and I have a pair of angles in angle 2 and angle 3. So I need one more pair of something. And as you guys look at this diagram, there is nothing else I can say in those two triangles that are going to be congruent. Nothing. Nothing. You don't tell me 7 and a 6 are alternate interior, so they're congruent. You need parallel lines for that. I got no parallel lines. There's no other sides it looks like can be congruent either. All right, so right now, those two triangles I need are not congruent at this point in the proof. So as we've done already, find me a pair then that are congruent. Look at this entire diagram, find me two triangles that you can prove congruent at this point in the proof. And they're the two big ones, angle BAD and angle ADE. You guys see the two that are right on top of each other, BAD and DAE. I already have side, side, and after I say AD is congruent to itself, I'll have side, side, side. So, yeah, reflexive. Triangle BAD. Congruent to BAD. EDA. Side, side, side. Here comes the tough part. Find me a pair of sides or angles in those two side, side, side triangles that are also in the two I'm looking for. All right, remember those two triangles? I only had a pair of sides and angles, and I was missing a pair. I need to find a pair of angles or sides that are contained in both those sets of triangles. So you search, and you search, and you search for sides and angles that are common in both pair. And then hopefully you come up with, oh, hey, I see that angle 7 and angle 6 are in both sets of triangles, right? Angle 7 and 6 are in the side, side, side triangles. And they're also full angles in the highlighted ones I have up here right now. And I didn't highlight those correctly, did I? Let's try that again. How about this triangle with this triangle? There we go, much better. You'll see that 7 and 6 are in both sets. So because I just proved the two big ones congruent, CPCTC says 7 and 6 are now congruent. And now you should, yep, we definitely have enough information to prove the two I need congruent. So I have triangle FAE congruent to triangle. If I go FAE, I hate doing this, FAE CDB. Angle, side, because that side is not in between. Okay, AE is not in between 7 and 3, and BD is not in between 2 and 6. So that's why I'm picking angle, side. And finally, why did I pick those two triangles? So I could say BC was congruent to EF, CPCTC. All right. I also want to mention, and I think I put this on the answer key, this wasn't the only way to do the proof. Remember how I picked those two triangles at the beginning because I had the most information about it? Okay. Well, if you wanted to pick the ones on the left and right, you could have proven these two congruent and then done CPCTC. Okay, you could have proven those two. Again, we had BA congruent to DE. Remember we had angles 1 and angle 2 and 3 congruent. You could have said supplements of congruent angles are congruent to get 1 congruent to 4. Remember when we proved the big triangles congruent by side, side, side? Instead of using 7 and 6, you could have used 8 and 5 CPCTC, and then those two triangles could have been proven congruent by angle, side. Okay, so that was another way of getting to BC congruent to EF. All right, just probably 2 extra steps maybe, proving those two outside ones congruent. All right, other questions you'd like to ask? Anything else, you guys? Topics, specific questions? Go right ahead in your show. That's it? Nothing else for me? Now, I know all the questions I've been asked today have been on proofs. I realize that, but also realize there's only 2 proofs on the test. All right, only 2 proofs on the test. Make sure you look back, you know, your isosceles triangle vocabulary, base angles, vertex angle, legs, base. Make sure we all know what they're referring to. I mentioned earlier in the review, read everything carefully tomorrow, especially on any algebra questions. All right, read everything carefully. Don't forget about the HL method. I'm sure that'll come up somewhere. It's just more. It's more than just two proofs. Remember, it's more than just two proofs. Okay, I know that's the big part and the part you're probably worried about, and what might be the toughest part. But remember, there's also other parts to this as well. Last call for questions. Last call. Anything specific questions or topics that you guys have for me? Yep. Right here. Here we go. Let me just copy and paste those real quick. Yep. Different names and different triangles. Again, guys, this is coming from one of the Google Classroom files I had posted. There's two of them, a tougher triangles one, and then the other one, which is, I believe, is extra practice. This is where I'm getting it from, the extra practice one. It's the first problem on there. Okay, it's asking us, this is like a two-part question. First part is, can you name these triangles based on their side lengths? So let's go through and do those first. All right, let's name each triangle based on their side lengths. All right, based on their side lengths. This first triangle right here, I have one hash mark and two hash marks and nothing on the third, so no sides are congruent. If no sides are congruent, we say that's scalene. Okay, that's a scalene triangle. Next one, same thing. You guys see the next one. All three sides are different lengths, so I call that scalene again. Third triangle, you'll see two sides are congruent and the third side is not. So if two sides are congruent, we call that isosceles. And finally, all three sides are congruent in a triangle. We call that an equilateral triangle. So that is naming it based off the information I'm given on their side lengths. Second part of this question is, all right, name it just based on the angle measures now. Angle measures. Triangle number one, I have 30 and 89. You can go ahead and find the third one. It's probably going to be acute. So if all three angles are less than 90, all three angles are acute. That's an acute triangle. Okay, all three angles less than 90. Next one, I got my good old symbol, my right angle symbol right here. So this has got to be a right triangle. Third one, yeah, you guys know these angles are equal. You can find them, but it's not going to matter. If I have one angle measure that is bigger than 90, one angle that's bigger than 90 in a triangle, automatically obtuse. Don't care if the other two angles are congruent or not. If I have one angle bigger than 90, it's obtuse. And then finally, if all three sides are equal, that means all three angles are equal. In particular, they'll be 60, 60, 60. So yeah, you could call this angle acute. You could call this triangle acute. Better name for it if all three angles are equal, equiangular. Equiangular. Okay, I would definitely also accept an acute triangle there because it is. All three angles are less than 90, so acute would be fine too. Just a better name would be equiangular for it. Okay? Other questions that you guys have? Last call. The same one I got these triangles from? Okay, number 6. Same set of questions here. Yep. Okay, angle measures of a triangle are in a ratio of 5 to 6 to 7. Find the angle measures of each of the triangles. All right. Anytime I have numbers in a ratio, because if I just take a triangle and put 5, 6, and 7, That's not going to make any sense, right? It can't be 5, 6, and 7 degrees because I know they add up to 180. So instead is with the 5, the 6, and the 7, I'm going to need to multiply 5, 6, and 7 by the same number so that when I add them up, they'll give me the amount of degrees and the interior angles of a triangle, which is 180. Okay, so what number should I multiply 5, 6, and 7 by? So when I add up all the angles, it gives me 180. That's why I always put X's anytime I see numbers in a ratio. And then from here, 13, 18x equals 180. X equals 10. Here's what I was talking about earlier. Read the darn problem. Great job, you found X, but unfortunately, it's going to get you only partial credit and not full credit. You didn't answer the question. I'm asking to find the angle measurements of the triangle. So I take 10, plug it back in. I'll have 50, 60, and 70 when I plug 10 back in for X for my 3 angle measurements. And I do a quick check, 50 plus 60 plus 70, yep, that does equal 180. So here, these are my 3 angles. If I asked for, hey, what type of triangle it is, acute triangle, right? All 3 angles are less than 90. We just discussed that would be an acute triangle if I asked a follow-up question there. All right. Great questions here, guys. Great questions. Any more?
Could you do an example of how to use hypotenuse leg or how to find that?
Sure. Let's see. Hypotenuse leg. That's what I'm doing here. Okay. Okay, so I have 2 triangles in this diagram right now, ADB and DBC. Very easy question could be name a postulate why these triangles are congruent. Okay, determine why, if possible. You know, not possible is always an option with these questions, but if possible, name a reason. So I first see, okay, the right triangles right now. I have these 2 sides, AD and BC congruent. And I also know at this point, at the end of Unit 4 here, that I can mark DB being reflexive to itself. So now I look at those 2 triangles and I say, ooh, all right, notice where the right angle is. The right angle is not in between the 2 sides. And there is no such thing as side-side angle. So I don't want to write that down. But I do notice, oh, wait a second. Wait a second. They are right triangles. The reflexive side, DB, is across from my right angles. So that makes it the hypotenuse. The side across from the right angles is called the hypotenuse. And the other 2 sides, in my case, BC and AD, are called the legs. So this is an example of HL. All right, it's not side-side angle. I can't use that. The angle's not in between, so it's not side angle side either. But I do notice, again, DB, the reflexive side, is the hypotenuse in the right triangle. And the other 2 sides are the legs. So again, if I just draw out a typical right triangle here, hypotenuse across from the right angle, other 2 sides are your legs. So I do have the hypotenuse congruent to itself in BD and BD. There's your hypotenuse. And then AD congruent to AD, or sorry, AD congruent to BC. There's your leg. So there's HL. If I was writing an actual statements and reasons proof, I'd say BD congruent to itself, reflexive. And then I would remember, if you're using HL in a proof, I would need to say triangle ABD and triangle BDC are right triangles. And your reason would be right triangles have right angles. Before saying they're congruent by HL, you need to tell me you have right triangles before using HL. So there's a little quick recap of using HL. Other questions, guys? Keep them going. Anything else? Okay. If there is nothing else, if you guys have a last minute question before, let's say, 8:30 tonight, feel free to email me. I'll try to get back to you tonight if I see it. If not, I'll see you guys second and eighth period tomorrow, getting after this, right? First grade of the second quarter. Start off on a great note. All right, I will see you guys tomorrow. Thanks for joining me and taking up some of your Sunday night. All right, have a good night, guys. See you tomorrow.
Thank you.
Thank you guys thanks for joining, guys.